Welcome back to the gretl Instructional Video Series. In this video, we will be learning how to use gretl to estimate an ordinary least squares regression and interpret the results. The only file you will need to follow along with this video is the gretl file real estate. The four items that we will learn in this video are how to perform an ordinary least squares estimation, how to create confidence intervals for the coefficient estimates, how to perform joint significant tests, and how to save the residuals. Now let's get started by opening the data series in gretl. To do this, open the main gretl screen. Click on File, followed by Open Data and User File. Now you have to locate the directory in which you saved the file. This is the same file that you used in video 2. Once you have located the file, double-click to open. After you click OK, you will notice that there are 6 variables that open on the gretl main screen. The first variable is the price of a house in market X. The second variable is the square footage of the house. The third variable is the age of the house. The 3 remaining variables are dummy variables, being equal to 1 if a house is located close to a university, if a house has a pool, and if a house has a fireplace. We will use this data to perform an OLS regression. The regression that we want to estimate is price is a function of a constant, square footage, age, U-town, pool, and fireplace. We expect the coefficient estimates to be positive for each of the variables except for age. Now let's go back to the main gretl screen to perform this OLS estimation. To estimate the OLS regression, select Model from the main menu on the gretl screen, followed by Ordinary Least Squares. A window pops up. Now we can enter the dependent and independent variables. To enter the dependent variable, click on the variable price so that it is highlighted in blue. Now click on the blue arrow to enter it as a dependent variable. To select the independent variables, click on square footage and drag your mouse down to fireplace. Once all the variables are highlighted in blue, click on the green arrow under independent variables. Another option is that you can add the variables one by one. Once you have entered the dependent and independent variables, click OK. The output for the ordinary least squares estimation will open in a new window. Now that we have performed the OLS estimation, let's learn how to interpret some of the items on the OLS output. First, let's look at the coefficient estimates. The output indicates that for a 1 square footage increase in the size of a house, the price will increase by $83. It also indicates that for a 1-year increase in the age, the price decreases by $193. All 3 dummy variables increase the house price, with the increase being $60,196 for being located close to a university, $4,353 if a house has a pool, and $1,399 if a house has a fireplace. Now let's use the OLS output to determine whether or not the coefficients are significantly different from 0. The easiest way to do this is to use the p-value for each of the coefficient estimates. The OLS output reports this p-value in the very right column. The p-value indicates that at a 5% level of significance, all of the variables are significantly different from 0 except for fireplace, which is a p-value that is equal to 0.1525. Another important piece of information on the output is the r-squared. In this case, r-squared is equal to 0.8686, and it indicates that 86.86% of the variation in price can be explained by the variation in square footage, age, and the 3 dummy variables. Notice that this is slightly higher than the adjusted r-squared, which adjusts the sum of squared residuals for the degrees of freedom, which is the difference between the sample size and the number of coefficients being estimated. This means that the adjusted r-squared will never be larger than the r-squared. Now we're going to move on to our next topic, creating confidence intervals for the coefficient estimates. The confidence intervals tell us the probability of obtaining values with these ranges if we were to sample repeatedly. Let's go back to the OLS output window to create the 90% confidence interval for the coefficient estimates. To create the confidence interval, click on Analysis from the menu from the OLS output window, followed by Confidence Intervals for Coefficients. A new window opens with the 95% confidence interval. To change this to the 90% confidence interval, click on the alpha to the right of the magnifying glass. In the window that pops up, select 90% and then click OK. You will now see the variable, its coefficient, and its 90% confidence interval. For example, the 90% confidence interval for square footage is between 80.43 and 85.94. Now let's move on to our next topic, performing joint hypothesis tests with linear restrictions. We're going to use the OLS output to perform this test, so make sure not to close the output window. The joint hypothesis test that we're going to be performing is the overall model significance test. The null hypothesis is that each of the coefficients excluding the constant are equal to 0 against the alternative that at least one of the coefficients does not equal to 0. To perform this test, go back to the OLS output window. On the menu of the OLS output, click Tests, followed by Linear Restrictions. Now we have to specify the restrictions. Type the 5 restrictions that we have specified under the null hypothesis. Follow the exact formatting to perform the hypothesis test. The first restriction we have to write as follows: lowercase b, open square bracket, uppercase s, lowercase q, lowercase f, lowercase t, close square bracket, equal sign, 0. We have to repeat this formatting for the remaining restrictions. The easiest way to do this is to copy and paste the first restriction 4 times. Now all you have to do is change the variable name. Make sure that in each of the variables, the first letter is an uppercase letter, because this matches with how we inputted the variables on the main gretl screen. If you are following along with this video, you may want to pause the video for a few seconds to give you a chance to enter all of the linear restrictions. Once you are finished entering the linear restrictions, you can click OK. A new window opens with the p-value and test statistic for this hypothesis test. In this case, f is equal to 1313.84 and it has a p-value of 0. This means that we reject the null hypothesis and conclude that the overall model is significant. Now open the OLS output window on the right side of your screen and the linear restriction window on the left. The overall model significance test is actually reported on the OLS output. By comparing the F statistics, you can see that they are identical. We went through this test a long way because now you know how to perform hypothesis tests with different linear restrictions. You do not have to restrict the hypothesis to equal 0. You can also restrict it to equal any number, as well as you can include addition and subtraction signs. Now let's move on to the last topic covered in this video. The last thing that we are going to learn is how to save the residuals. After saving the residuals, we're going to look at the summary statistics. It is expected that the mean is equal to 0 because we have included a constant in the OLS estimation. To do this, go back to the OLS output window. Select Save from the menu, followed by Residuals. A window opens asking you to name the new variable. I will leave it as the default U hat with a description residual from Model 1. Now click OK. To create the summary statistics, go back to the main gretl screen. You will notice that the variable list now includes U hat 1. Left-click on U hat 1 so it becomes highlighted in blue. Now right-click on the blue area and select Descriptive Statistics. In the new window that opens, you will see the mean value of the residuals. It is equal to 7.74 times 10 to the power of negative 12. This means the number is very close to 0, as expected. We have now finished learning how to use gretl to estimate an OLS regression and interpret the results. When exiting gretl, you do not need to save the changes made to the data file. Before wrapping up the video, let me summarize the 3 key points to remember. Number 1. It only takes a few clicks to estimate an OLS regression in gretl. Number 2. Make sure to understand the interpretation of confidence intervals because they are commonly misunderstood. And number 3, you can use gretl to perform a joint hypothesis test with linear restrictions. This concludes the third video in this series.